What's up? This is James, and this is the video log of me developing my pet robot idea. Going through all of these parts, a couple 3D prints, and a lot of sidetrack mistakes to make this thing. For this project, the main idea is that I want the robot to be and act similar to a pet. To do this, I set three main goals for what I wanted the end result to look like. 1. I wanted this to be able to roam around on its own. Roaming around would give it the feeling that it gets curious and starts searching the room. 2. I want it to be able to do some independent actions, something like having colored blocks it organizes or little games it plays with itself. 3. I want it to look like a pet when I finish, maybe adding some cute eyes or funny sounds. For this video, and over the last year, I mainly focused on part 1, getting the robot to wander on its own. This was my first idea at achieving these goals. The designed robot would have a main body with wheels that would allow it to roll around the apartment. Its neck would be controlled by a servo motor, and its head would be a screen at the end of the neck that could be used to animate the robot's face. I also came up with the idea that it could have some arms out front that could be used for picking up things in the future. Turning these ideas into a first prototype, I bought this pre-built metal chassis with omnidirectional wheels and motors. Then I worked with my uncle to fabricate the wood pieces for the head, neck, and arms. This was a great starting point, but it became clear that woodworking was not going to get me where I needed for this project. I needed a 3D printer. So, through some eBay magic, I got one. As you can see, the servo that we used with this new and improved head was not strong enough to lift the servo up from the bottom. Once in the upright position, it's able to hold and move stuff around to some extent, but once the neck got all the way to the bottom, the servo did not have enough torque to raise the head back up. So, back to the drawing board. We redesign a new neck and use a much larger, much higher torque servo. With basic design for the neck built, it was time to tackle how Rec was going to move. I knew I would need to power both the computational unit and the motor unit eventually, so I designed this system where both units were powered from a 2-output portable charger. This would give me a regulated and maintained power output and a built-in recharge system. From here, I began testing the different movements with the new system and the omnidirectional wheels. These tests produced just how differently it would function on carpet versus hardwood. So it was back to redesigning with the new wheels. After purchasing these standard wheels, I tested the same motions with the same motors. While this should have produced the same results on paper, the power from the portable charger was barely enough to move forward and backwards. When testing Turning Rec, the voltage didn't provide enough torque and the system was stalling out. With another setback, I set myself on getting a chassis where the wheels turned like in the front of a car. To achieve this goal, I went through months of CAD design for a 3D printed chassis. I was trying to build a system that I could just then include on a giant 3D print of the shell later. In the end, I spent way too much time trying to design and print something that never worked the way I needed it. I was still learning CAD and how a printer worked, and honestly, mechanical design was just not my best skill. So after struggling for months, I remembered that I do have adult money and found already a designed version. I decided I was going to buy this Anchorman chassis as it came with a lot of improved features. However, the new system needed a 12-volt battery. So I ditched the portable charger and redesigned the system. Now we have a power board for the Pi, a buck converter for the servos, and power to the motors. This worked great for the first 3 minutes of testing. Then the motor controllers just went black. I don't know exactly what happened, but those things are done for. The motor that came with them had a built-in communication scheme that made it a lot of work to try and replicate those motor driver controllers. When I went to go buy a replacement, the Chinese website was very sketchy and I could not get an order through. So instead of increasing the cost more, I decided to try and use the old motors in place of the rear motors on the chassis. This involved printing out some simple parts and using the old motor controller, but after testing it worked great. But the old motors running off the new battery ran way too fast. This new battery could deliver significantly more voltage and current, so I made some slight modifications to the power system to keep the speed down, mainly just changing the motors to be run off the buck converter, which would lower torque and provide a workaround current limit. Now with the movement capabilities for the neck, the wheels, and the steering, it was time to put some code in and see how it all came together. Coding at its simplest is a giant flowchart for how we want to handle inputs. Here's a giant flowchart explaining my logic and flow for my first roaming heuristic. Skipping over all the monotonous details that this flowchart provides, the simple explanation is that if it senses something, it backs up and turns away from it. This put into code looks something like this. I have conveniently skipped over the many iterations of this code, as this video is already long as it is. But for the record, what you're seeing is version 7 of the roaming code. An important note so far, I have not mentioned any of the sensors on the system. So far, they have all been actuators. I first attempted to use 2 ultrasonic distance sensors attached to Rex's head slightly to the side, hoping these sensors would sense walls approaching from both sides. However, these sensors weren't in the correct places to pick up floor objects and miss walls directly in front of Rex. So I revamped the entire system one more time with a bunch more IR distance sensors, hoping this would give a more thorough system with fewer blind spots. Okay, after all of this, time to test it out. What did we get? Yeah, unfortunately it looks like switching to all IR sensors did not pay out. I don't have good video of it, but the sonic distance sensors were sensitive enough I could read objects from further away, and Rec could turn away from it. These IR sensors are interfered with way too easily, and unless the wall is right in front of Rec's face, he doesn't see anything. So this is where I currently stand on the project. I have lots of ideas for future progress. I plan to look further into ways of slowing the motors, as they still run way too fast, and I plan to also reevaluate the distance sensors and find a good system for object detection. While I know there's still a long way to go, I wanted to share all the mistakes and progress I've had on my project so far. Hopefully by the next video I will at least have it roaming. Thanks for watching!